Hi, welcome back to the statics review session. In this session, we learn how to draw a free body diagrams. Free body diagrams are very important in solving complicated statics questions or problems. It's actually makes it simpler once you see the system and you see the reactions, and then you can continue by finding support reactions or drawing shear moment diagrams. But the first step is always drawing a free body diagram. So we start first by a coplanar concurrent force system, or 2D, and concurrent means that all forces just intersect in one point. This is what I mean concurrent force system, and coplanar because we're working in a 2D. So if we need to start, for example, finding what is the if the weight of the box is given and we need to find the tension forces inside these cables, the first step is always drawing a free body diagram showing the forces or disconnecting the this that train from its surroundings, and then replace these with arrows to represent the force and whatever is given. So we start by drawing the two axes because we're in a 2D, x and y, and having this point as point B, then we can start by giving that weight of that box and representing that force, and we can give it as FC or FBC or BC only, whatever you like, and then finally that line FA. Important giving all information that will help also in the calculations, which in that case here, this angle 30 has to be also given in that case. So this is a simple problem where coplanar concurrent force system. We wanted to go into the calculations, but just drawing the free body diagram. So how can we then draw a non-coplanar concurrent force system? This means that you have non-coplanar, we're talking 3D, XYZ. Concurrent means that they all forces meet at one point, here in that case at point A. Again, we start by drawing the 3D axis, XYZ, and then starting with the given force, in that case the weight of that box, and then representing the forces. In that case you have force FB and force FC and then force FD. This is the free body diagram. You can use then these dimensions in representing the forces Cartesian vector form. Remember, when you have dimensions like that, what method? Remember, we said there are three ways to represent a force in Cartesian vector form: either direction angles, we don't see here any direction angles, or projection information, we don't see also these two triangles, or position vector. Whenever you see dimensions like that of coordinates, then you know that you have to work with a position vector. We'll talk about this in next sessions. So the following is how to find or how to draw a free body diagram for a coplanar 2D non-concurrent forces they don't meet in one point force system. This is a very typical projects or examples for in working with, for example, civil engineering projects. The important step is first to draw the line that represents the system or the structure, and then all the forces applied upon them, all the external forces. So here you have distributed load, and you have single load or concentrated load with an angle, and you have another single load with or concentrated load 120. So the first step is drawing the external loading. Now, if you look, this system is supported with two types of supports. In 2D, there are three types of supports. Here we have the first two. One, this type of support is called pin support. That pin support will allow rotation, but it will prevent motion along the y or these two directions, the x and y directions. And then you have a roller support that will allow rotation and also allow motion along this axis, but it won't allow motion along the vertical axis. So whenever you think what kind of reactions you should draw as forces, you always think what this support will prevent from in motion or rotation. So it will, you look at the y-axis and it will prevent motion, then you place right away AY. This is a force A in the y direction, and it will prevent, because it's a pin support, it will prevent motion along the x-axis. Then you just place the AX. It will not prevent rotation. This system can rotate. In about this axis or this support, it will prevent motion along the vertical direction. Then you place right away BY. It will not prevent motion along the x-axis, so you don't place a reaction, and it also will not prevent rotation. So this becomes the free body diagram. The important here is these three reactions. So that system has to be resisted by the type of supports where it will have these forces. And by the way, whenever you draw a these forces, you can give any assumption of any direction. Like I could have drawn this downwards, or I could have drawn this on the other side. It doesn't matter. Calculation, you'll see in the coming sessions, calculation would show you what is the correct direction of that force. The third, so these are the two types of supports. The third type of support is called fixed support. So if this beam is supported by only that support, then obviously to have it stable, it should prevent it from moving along the two direction, and also prevent it along or to rotate. Otherwise this will fall. If this would, for example, would have been a pin support like that, then this would fall right away. So which means that you have to also prevent it from rotation. So again, the system, we draw it showing the external forces, and then look at the support. It will prevent from motion along the vertical axis. Then I place and I give it AY. Will prevent it motion along the x-axis. I place the force reaction AX, and it also will prevent it from rotation. Then I place a moment around this point and I give it MA. So these becomes the three support reactions at this support at point A. Following, we will see how to calculate in the coming sessions, but this is for a coplanar non-concurrent force system. So let's see if we put none in both sides. So then you have a non-coplanar, non-concurrent force system. This is an interesting thema or subject. So you have a 3D forces that are not connected to together, and the first step here is, if we would draw the free body diagram showing the forces, now we need to put support reactions. In 3D, if you review the table given in a textbook, or any textbook about support reactions 3Ds, there are different types of 3Ds. Again, the important part is always looking at a support and think what direction it will prevent motion or rotation. These types of supports, it's called journal bearing. Journal bearing means that it can rotate about its own axis. So there's no prevention of rotation about this axis, and it also will move along that axis, in that case here along the z-axis. So if we would like to place, if you look at that table for journal bearings, actually it will you will see that it has drawn two force reactions and two moments, but placing another types of support here, in that case the journal bearing, it will cancel this moment rotation. So you have also to be very careful. This happens also to a hinge types of support. A hinge that you see in the door, it would, if a door was supported with only one hinge, then it will prevent motion along the three axis and rotation about two axis prevention. But placing another hinge in the door will cancel this rotation effect, and you will have the hinge only three force reactions. So back to this support. Again, you look at the support and think, let's look at the x-axis. Will it prevent it from moving along this axis? Yes, it will prevent it. Then you place ax. Will it prevent it from moving along the y-axis? Yes, it will. Then you place the y-axis. Will it prevent it from moving along the z-axis? No, it will not prevent it. Then there's no reaction. Moments are cancelled. Otherwise, it would have also prevented about the x-axis and about the z-axis. Sorry, about the y-axis, because the z is actually, it is designed to rotate about the z-axis in that case. If you look at the journal bearing at B, but because we place this B, then it cancels this moment rotation effects that are acting at this being. And then you have all that you have to do is that these two support reactions. So look at B. Will it prevent motion along the x-axis? You answer yes, it will prevent it. Then you place bx. Will it prevent it along the y-axis? No, it won't prevent, because the journal bearing is designed to move along this axis, so I don't place reaction. Will it prevent it along the z-axis? Yes, it will. Then I place the bz. The same thing at point C. It will not prevent motion along the x-axis, so you don't place x. It will prevent along the y-axis, and it will prevent along the z-axis. So this becomes the free body diagram showing the support reactions at the three supports A, B, and C. This is considered like in a 3D. You have six unknowns, and you'll learn when we start covering in the coming sessions how to find these support reactions. So again, the final note, it's important to always analyze each support, what it will prevent, and you place the reactions. This is one thing. The other note, it doesn't matter what direction you place the reaction. You see, I placed this reaction this direction. I could have placed it on the other direction. As long as you just put the reaction, the calculation will show you what direction that is. So if you get a negative answer, it means that it has to be in the opposite direction. So this wraps up this session about drawing the free body diagram, and you will see how we use that and how it simplify calculating or solving statics problems. Thank you.